first we'll start by importing the necessary libraries, which is these for this specific project. Okay, and then next, as well as most of you know, these green lines are comments, which not technically is necessary, but you pretty much always want to have comments in some way. Maybe not for every single line, like here. I don't have it for all 4 of these lines, but I have it because all these lines are doing the same action, roughly. It's going to be there. So it is definitely helpful, both for anyone who you're showing your code to in your project to, as well as yourself to remember if it's something new that you're working on. Okay, so let's now define the folder that, as you can see here, define the folder that is containing the data sets. Okay, so it's where the data files are stored, basically. This is important so that Python knows where to look for your data. So data underscore folder, that's just data folder, because you don't do skips or spaces, so if you just have to do underline, and then which is equal to datasets, which is what your file will be called, or your folder will be called. I apologize. So this sets datasets as a folder where all the CSV files are stored. Pretty simple. The first few ones in your code are always going to be the most basic and straightforward of what it is. Okay, and then so here we're creating a list of the CSV files that we're wanting to analyze. So make sure that these files are in the datasets folder. So make sure these files are in that folder. And make sure each name is exactly how it is named. If you have one letter off, it will not work. You have to make sure it's exactly how it's named, including .csv. With these, that just comes with it. That's just, I've used it to where I didn't use a hyphen, but you want to add a hyphen if that's already in there. So this is just an explicit list of CSV file names. These are specifically files that are having to do with the Jewish population and all. So next, after going through that, is next. So now we're going to loop through each file and load it into the pandas data frame. So let's see. So for the file that's in the CSV files, for whichever file, you go to the file path, the operating system path, and you use that data folder and that file that's in the data folder with it. And then you're going to be loading the CSV file into the data frame. And this goes for every single file you're using. It's not just going to do one, and you have to rewrite the code, do another. It's going to do all of the files. So whichever CSV file, so for now it's 1, 2, 3, 4, 5, 6. You load that CSV file into a data frame. And the data is equal to the panda.read CSV. So as you can see here, it's reading the CSV files, it's going through our engines, and this is a lot that I'm not entirely honestly sure about, but I'm still learning. But that's what it is doing. So it's pretty much just reading the CSV file and its file path, and then it's printing out. Here it is trying to read the CSV file into a data frame, which is just a big data warehouse. And if the file's missing or it's going to be corrupt, Exceptions will be handled later in the code, which I'll show you. But that is that. Oh, here. So this print data.head, that's going to display the first few rows for quick checks. So the first few rows of the CSV file itself, all of them, just to make sure it's working. I apologize. So like I said, it shows a preview of the first 5 rows. Next. Okay, next we're going to this is the part that it's not very glamorous, let's say. It's data cleaning. Yay. So, as I said earlier, real world data is often messy, and you have to clean it up. It's what it is. Like, let's say it's 10 lines of code, 10 rows. You honestly sort of want to do that by hand because it's quick. You can make sure there's nothing missing. But if it's hundreds, that's when a lot of times it's easier to use Python or another project, another program that can help you mine it and clean it. So you see this, as it says, cleaning numeric looking columns by removing unwanted characters. That's my comment I have for it. So data cleaned equals the data copy. This creates a copy of the data. This creates a copy of data to keep the original untouched. So this data, it will clean it, and it will also copy the original data to make sure it's untouched. And then for all of this all itself is, okay, so for each column in the data cleaned, it'll pretty much do the same. It keeps a clean column of it. That's pretty much what that's doing. And then each AS type, that will be converting to string to process text-based cleaning. So it will go process these all to strings. After that string, you replace each comma. You remove each commas. You remove the percent signs. And you also strip and trim white spaces. So, yeah. And then this, it is converting the clean data back to numbers. So the data that was all just cleaned, you're going to convert that back to numbers. And the invalid here, the invalid values that are going to be invalid, as we stated earlier, if there's any, will be set to NaN, which is sort of a way of saying not acceptable in a way. Yeah. Okay. And next, also NaN stands for not a number, not a number. So now with our data cleaned, we're going to look for correlations. We'll focus on numerical columns. So here you see the select only numerical columns for the correlation analysis that will go with all these columns. So the numeric data, which we just cleaned and put back into numerics, that will be selected by dtypes. So this is just saying extract columns that contain numeric values only. Include any that have numeric values only. That's simply what that means. And then the print, so what you're going to print out, it'll print out numeric columns found. That's if they're found. If it's not errored. And this will display a list of numeric columns that were found. Next. So compute the correlation matrix. to assess relationships between the numeric variables. So, correlation matrix, which is what we're using, is the numeric data. So this is going to compute the correlation, and as I said here, it's going to compute the correlation matrix. So it's going to take all the numeric data and assess the relationships that are between each numerical column of value. And then this print correlation matrix for whichever file it is. It'll also print correlation matrix. This just displays the correlation matrix itself. And if I haven't explained already, correlation matrix is, how do you explain it? Correlation matrix is the correlation, so what is similar, what's the relationship, that between the matrix. So is the matrix is like a whole universe in itself of data sets, and it involves all the data. So that's what that is in a very broad term. Yes. Okay, so like a value of 1, let's say, which we're gonna be showing here, but I'll state it now. A value of 1 is a perfect positive correlation. A -1 value means a perfect negative correlation, and a 0 means there's no correlation. So it goes back to regular positive and negative integers. It's pretty simple in that regard. Excuse me again. So next, let's make things visually appealing. Yay, fun stuff. We're going to create a heat map that's going to visualize that correlation matrix that we have just made. So here we have, if it's not correlation matrix, it's empty. So extract the strongest correlations that are above 0.7. So each correlation of pairs in the correlation matrix, you unstack those, so here it's stated as return a data frame having a new level of column labels that consist of pivoted, so changed index labels pretty much. So you're going to extract the pairwise correlations, you're going to sort them in a descending order. Ascending equals false, that means it's going to be descending. And that's what that means. You're going to sort the values in a non-ascending. And you're going to filter out those correlations above 0.7, excluding the self-correlations, which are 1. So between 0.7 and 1. And you're going to display only the top 5, which is stated here. The head of 5 is going to show the top 5. It won't show any more unless you want it to. Next. So next is print summary of the strongest correlations. Pretty simple. If not, the top correlation again is empty for variable 1, variable 2 for the value of the integer of the top correlations and the items. So let's show, and then else print the no strong correlations above 0.7 are found. That is of course what's all going to be printed out. Then with all of that done with the top 5 correlations, all the actual data, I'm going to create a heat map visualization to show all of that correlation matrix. So again, PLT, the matplotlib pyplot figure. So the figure size is going to equal 8.6. The Seaborn heat map, so it's going to be the correlation matrix annotation true. The CMAP is going to be cool and warm, so cool, warm colors, cool to warm. FMT is going to equal 2F. PLT, the title of the plot, will be correlation matrix, whatever it is. And there's going to be a tight layout, so it's going to be tight, it's going to be fit, and it's going to show it. So it generates a heat map. It's using the seaborne to make correlations that you can tell what they are. It's going to use this color schemes. It's going to display the values directly on the heat map, and then it's going to show the plot once it figures all that out based on all that you've put in. And then you skip the file if there's no numerical columns found. Also, I did not state what that is. I am sorry. FMT equals 0.2F. That's to format to 2 decimal places. Then, like I said, it shows. So now it is important to also handle errors. You always want to handle errors. If you don't, it's going to make more errors, and you're going to be wondering why so many errors are happening out of nowhere. For example, if a file is missing or empty, your code needs to handle it gracefully. So, here I have all that except file not found error. So you put error, whichever file it is, it's not found. That simply handles missing file, and the same with the other, except the pandas error, empty data error, whatever file is empty or corrupt. Those are usually empty or unreadable files. That is the basic code for our project. So here we use the try except blocks to catch potential errors. If a file not found error occurs, we print an error message, as I said, and the same with PDs, seaborns, all that. And there you have it. So we've loaded, cleaned, analyzed, and visualized data. We've learned how to use pandas to load and clean the data, to calculate correlations, and create heat maps using seaborns and matplotlibs, piplots. Remember, data analysis is a iterative process. You might, and usually you will need to go back and refine your cleaning steps, because often you could have a basic version of this within in a week's time, and if you're still working on it, there'll be so many ways you're going to want to change it. Better wording, add more things, and with adding more things, you're going to have to change what you already had. So like I said, you're going to need to go back and refine your cleaning steps and try different types of visualizations depending on what you want to add or subtract from your code. If you want to learn more, I suggest checking out pandas, seaborns, and matplotlib documentations, trials, stuff like that, tutorials, and I did not erase that, but here is this. There we go. That is the summary that is of this. My VCR is not loading. Could be because I have another tab open. Let me clear that. Let's see if it will run now. So like I said, there's all of our process. So Finland, Europe. That is, there's going to be no numerical values for Finland and Europe. Look at that. And neither for Bulgaria. 5 rows by 8 columns of each the CSV, again, percentages, and then we have a small summary down here saying what it is. The pre-war Jewish population and number of Jewish people that were killed have a correlation of 0.88, and it just states it in a different way. The numbers of Jewish that were killed and pre-war Jewish population have a correlation of 0.88. Let's see. Once again, it is not showing my VCR. Usually it does. I'm not for sure what is happening. Let's go out real quick and maybe going back out and going back in. It will work. Let's try once more. Let's try once more. I apologize that this is not working right this second. Usually it does. While that's loading, hopefully, I do need to show you my report, which is something that often it is best to put into your project. So here's introductions of what the project is, the basic overview of what CSV file is what it is, the correlation of the heat maps, the line graphs, the findings, and what the conclusion is. And I also put notes and feedback. So there are plenty of feedback that I had gotten from my professor and other students of my class. There we go. I apologize. Like I said, my computer is weird. So here we go. The correlation matrix of country comparison CSV. This is just the first one that it chooses. As you can see, it's a heat map. So the country, the region, population. Then here, country, region, total population. It's the same thing, but it's on its side. And this is, of course, the highest and the lowest. And there we go. If you have a wonderful day, goodbye.